Hello, and welcome to another episode of Let's Do Some Data. I'm kidding, it's not an episode, but we are going to look at data. So, what I want to look at here is I created another set of data, and this is from growth hormone levels, just some made up stuff here. But what I want to show you with this one is with this data, I have 25 growth hormone levels. On the left-hand column, they're just kind of input as I collected them, fake collected them. And in the right-hand column, they are ordered growth hormone levels. And I want you to think for a second, which of these columns is a better description of the data? Well, the ordered, because it's easier to look at, right? So one of the things that I will say repeatedly is that one of the main goals of statistics is to give people the most amount of information in the least amount of time. This is the same amount of information. But if I look in the left-hand column, that's going to take me forever to slog through and figure out what kind of values I have. Whereas if I look in the right-hand column, I know right off the bat that about half of my data is less than 20 and the other half is greater than 20. And most of the data looks like it's maybe 50 or less. And then I have these huge numbers at the end and I have maybe some outliers there. I can figure that all out just by looking at the ordered data that much faster than the non-ordered data. So now it does not matter which of those I do my descriptive stats on. So I am going to grab these descriptive stats right now. My input range, I'm just going to use the GH, the growth hormone data. Again, it does not matter which column I use. It's grouped in a column. It has a label. Output D1 should be fine. Summary statistics is fine. And then I hit OK. And here are my descriptive stats. Now, what I really want to talk about this time is the distinction in the measures of central tendency and the measures of dispersion. So let me highlight them here for a moment. Okay, so I have a mean of 47.8 and a median of 27.2. Wait a second. Those are both measures of central tendency, yet they are very different, which means when I look at center, when I look at a typical data value, now I need to decide which one am I going to report back. Because if somebody said, hey, what's a typical growth hormone level for a person? Is it 27.2? Is it 47.18? I don't know. And with mode, it has NA because there isn't one single data point that happens more often than the others. So now I've got to decide, oh gosh, is the mean or the median a better typical data point? The mean has its benefits because that's every data value gets its own time in the sun. Okay, it gets its own 15 minutes of fame. All the data values are added together and divided. But when we look at the median, technically I have 25 scores, so that median is just the middle point. It's the 13th point. 12 on this side, 12 on that side, and the 13th point. In other words, the median ignores everything else, and it's the only thing that gets famous. And that seems kind of maybe not fair. Now, obviously, I'm talking about this and teaching it to you in very layman's terms, but that's sometimes people's hesitance about using a median instead of a mean. The mean is, well, aren't I supposed to look at everything? Now let's try to fix that. That trim mean that we talked about before kind of takes the best of both worlds with a median and a mean, because the trim mean chops off some of the ends but keeps the rest of it and then averages the middle. Since we've already used trim mean, it should be up here toward the top. I'm going to hit OK. And I'm going to highlight the array. I'm going to highlight the data right here. And I'm going to take off 10%. I get 38.4. Okay, so here's my other measure of central tendency. And that one looks pretty good. 38.4. I can live with that. And if I look at the ordered data, 38.4 is above the median, but it seems to take into account that most stuff is under 50, but we do have things above 50. I could probably live with 38.4. So if somebody asks me, what's a typical growth hormone level? I might say, you know what, I'm going to give you the trim mean, which is 38.4. Now, as far as the spread, this data is also very spread out. It goes from 3 to 292. And that seems a little bit crazy. So my range is 289.3. That's huge. And if I compare that range to the mean, that's a pretty big range. The standard deviation is more telling. And it says, okay, if my average is 47.18, most scores are within 62 points of that 47.18. And that is true. Now, we're not going to talk a lot about measures of dispersion other than to say the bigger they are, the more spread out the data is. Okay, so there's one more example of measures of central tendency. Now let's talk about something else. Let's talk about frequency distribution. So I'm going to go back to that household head data that we had before, and I'm going to plunk that down over here. And I want to figure out how many people are in each decade of age. So the first thing I'm going to do is I'm going to go to data, and I'm going to sort this from least to greatest by clicking on A to Z. And now I can look, and it looks like people in their household are from their 30s through their 60s. So I am going to create age ranges. If I could spell ranges, that would be helpful. And so 30s, 40s, 50s, 60s. Except Excel doesn't understand that. That's weird. So what we actually do is we give Excel what are called bins. And those bins would be from 30 to 39. Now, Excel doesn't understand 30 to 39 either, so what we're going to type is 39.9. What Excel wants when we create these bins to make a bar graph, a histogram, is we need to give the end point for each interval. So my first interval ends at 39.9 years of age, then 49.9, 59.9, and 69.9. Okay, there's my bins. So now I'm going to go into data analysis, and I'm going to click on histogram. My input range, I'm allowed to select labels, so my input range is going to be age of household head. And then my output range, not my output range, my bin range, pardon me, is my bins. And again, I'm going to include the label bins, okay? It seems weird to include that, but include it because we clicked on the fact that we were including our labels. So there's my input data, there's my bins. I need an output range. And my output range is going to be right next to where I first wrote the word bins, okay? All that really matters is it's in an empty spot, but trust me, this is where you want to put it. And I want a chart output so I can see a bar graph. So then I'm going to hit OK, and look at that. I have a bar graph. It's fantastic. Now, here's the thing. If somebody's going to read my bar graph, they need to really understand my bar graph. And this is a really crappy bar graph. So now you have to come in here and do some housekeeping, I guess. Is this a histogram? Yeah. But is that a good title? No. This is a count of decade or ages by decade. Okay. And I just clicked on that to make that work. Down here it says bins. I don't really want it to say bins. So I'm going to write age ranges. Okay, 39.9 is not an age range. How do we change these? Well, these populated based on my bins. Once Excel gives you an output, you can go in here and change this to 30 to 39 years, 40 to 49 years, 50 to 59 years, and 60 to 69 years. Now, if you don't write the word years, it might think you're doing 30 minus 39 and then write -9, which is obnoxious. So that's why I added years on there so it knows it's a text box. So there's my age ranges. That's pretty cool. More, well, there aren't any more. So I'm going to take this and I'm going to hit the delete key on my computer. Notice I did that and it left a blank bin. What we really need to do is we need to right click and then hit delete. And shift cells left is fine because there's nothing on the right. Now it gets rid of it. Why it does it that way, I have no idea, but you have to right click and delete it to make it disappear. Frequency, I don't really need a legend. There's only one color bar. So I'm going to click on this and delete it by hitting the delete key. Cool. The other thing is these bars are pretty far apart. So here are things you can do with them. I can make it wider. I mean, it made them wider, but they're still pretty far apart. I can make it taller. Ooh, that was helpful. Now I can see my frequencies a little bit better. The other thing you can do is if you click on a bar, okay, you'll see that these are all highlighted. Then if you right click and you go to Format Data Series, a little box should show up on the right. So let me move my face here. Here's the little box on the right. What we want to do is change our gap width. And I usually change that, I usually change that to 5. And now it makes them wider bars. A histogram purist, of which I am not one, a histogram purist would say if you have a histogram, they really need to touch. I don't care if they touch. I kind of like there to be a little gap so I can understand which bar is which. It's up to you. You can make your gap width 0. I prefer it to be a little bit greater than that just so you can see each individual bar. The other thing I want to do also is I'm going to right click again and go to add data labels. And I really like doing that because, again, most amount of information, least amount of time. Now I know it's 11, 14, 4, and 1, and I don't have to say, wait, is that 1 or is it 2? And squint my little eyes because I'm old and I can't see that much anymore. So anyways, that is how you make a histogram. Okay. And this histogram also gives me a good idea for which measure of central tendency is best. If I looked at this and I said, what's a typical age of a head of household? It seems like it's somebody in their 40s. And if I go back and I look at sheet 1, yeah, typical is in the 40s. Now let's do the same thing for those growth hormone levels. So I am going to go back to data analysis and do a histogram. Now, full disclosure, I'm doing something wrong right now, so I can teach you a lesson. I want to make a histogram. I hit OK. And then I realize, oh, crap, I need bins. You can't make a histogram without first deciding what your bins are going to be. So what I am going to do is get another clean page here. Control C, Control V. And now that's the growth hormones. But again, I can't tell what I want my bins to be unless I keep hitting the wrong tab, unless I sort it. And so now if I think about these growth hormone levels, I've got 3 all the way to 292. Counting by tens, that's way too many bins. So if I were looking at this, I'd say, you know what, maybe up to 20, and then 20 to 40, and then 40 to 60, and then maybe like 6. There's not a lot after that, huh? This is where that more column comes in, where you can kind of decide, what do I want to do with this? How do I want to organize this data to make it obvious to somebody that there's some kind of crazy outlier? You have a couple options. So let's say at first we go by 20s. So I say it's going to be 0 to 20. And then really, though, I want 0 to 19 now that I think about it. And then 20 to 39, and I go by 20s. Excel, very helpful thing. This would end at 19.9. This would end at 39.9. And I want to keep going up by 20s. Excel should be able to tell what I'm doing after just 2 of those. Oh, look at that. It's going up by 20s. Thanks, Excel. You're the greatest. That is all the bins I will need. So I am going to call this bins. And I am going to use all of these bins for my growth hormone level. So I'm going to go to data analysis, histogram, hit OK. My data is in this column, but it's highlighting too much right now. My bin range is over here. I want to include the word bins. I highlighted labels. I have an output range right next to this word bins. And then I'm going to hit OK. That is a histogram. And the great thing about this one is, whoops, I grabbed the wrong thing. The great thing about this one is I can show that there's a huge gap in the data. So if I look at this histogram, I don't need frequency. I don't need more. So let me delete that thing. Shift cells left, that's fine. If I want, I could go through here and say 0 to 20. Nope, I did it again. 0 to 19, 20 to 39, and I could keep going, but I don't want to right now. This is frequency of growth hormone levels. I can't really tell what these are, so again, I can click, right click, and add the data labels. That's really helpful. If I right click again and format data series, there it is. My face was in the way, and I change my gap width. Now I can see that a little bit better. Okay. So now when it says what's a typical data point, I might say, you know what, my typical data point better be something in here, or I'm not going to call it typical anymore. So when we go back to sheet 2 and we look at these measures of central tendency, I would say, yeah, that 38.4, that trim mean, that's definitely the best one for this case. Okay. So we've talked about descriptive statistics and making a histogram and making bins for that histogram. Now, one thing I haven't talked about, and then I'll wrap this video up, is when we talk about making your bins, you can go by 10s, you can go by 20s, you can go by whatever you want, 5s, 1s, doesn't matter. My general rule of thumb is have less than 10 bars for somebody to look at. Most amount of information, least amount of time. If I've got to look at more than 10 bars on a histogram, that's not a good histogram. Okay, that's my opinion. But typically, I would say your rule of thumb is less than 10, fewer than 10. Alrighty. Okay, so I am done with this video, and hopefully you feel like you learned something.